Right. It says quick review 5.7, but basically I'm going to go ahead and do all the examples in this section since we didn't talk about it in class. And basically it says applying systems of equations. So really what they're doing now is they're giving you story problems, and they're going to want you to write the story problems using two variables and form a system of two linear equations. And then, of course, use what we have learned in sections 5.1 to 5.3, the different various ways that you can solve a system of equations. So I'm just going to go ahead and start. Let's just do the first one. It does give you a chart on page 168 that gives you the steps. Now remember, there's several different ways we can solve story problems, but they're specifically asking you to do this by applying the systems of equations. So the first example says the sum of two numbers is 71 and their difference is 13. Find the numbers. Well, first of all, you need to identify what you know and what you don't know, right? So if we're going to do that, well, we know, right? We know that the sum of those numbers is 71. Whoops, 71. And we know the difference of those two numbers, correct, is 13, right? That's what we know. What we don't know, or what is unknown to us, is what is the two numbers. So I'm going to say let X represent the first number, right? And Y represent the second number. So the two numbers is what's unknown. Now, we have two is statements. So we can write two is, or two equations, using these two unknowns. So the first one is the sum of the numbers is 71. So if I take the first two numbers and I set it equal to 71, that's the sum of the two numbers. The other one is the difference of the two numbers is 13. So if I subtract the two numbers, I get 13. Excuse me. Okay. So now I have two equations with two of the same variables. So this is a system of equations. And from here, you can solve the unknown. So now looking at this, you have a choice. Remember, we've learned several different ways on how to solve systems of equations. You can solve by graphing, you can solve by substitution, and you can solve by the addition and elimination method. And so you kind of want to look at them and see which would be the best. And at this point, because these are both coefficients, one's a positive, one's a negative, then it probably would be good to go ahead and use the addition elimination method. So when I take x plus x, I get 2x. Y minus y is 0. All right, and then 71 plus 13 gives me 84. And then I'm going to divide both sides by 2. And I get x equals 42. All right, so we know what x is. X is 42. Then you're going to take one of your equations. Let's take the first one here. X plus y equals 71. I'm going to substitute that in. 42 plus y equals 71. And I'm going to solve for y. So y equals 71 minus 42. And y equals 29. So then at this point you can say that your solution, right, is 4229. That is your point right there. There's your solution. And we have now solved this by using the addition elimination method. Let's look at the next example. And you can they do recommend that you do your check step. Basically, that you would plug this into your two equations. So I would plug this in here and make sure it solves that one. And then I'd plug these two numbers into this one and make sure it solves. But I'm not going to take the time to do the check step at this time. All right, so our next story problem is a number is one more than twice as large as another number. Twice the smaller number added to 3 times the larger number is 59. Find the numbers. So let's talk about what we know and what we don't know. All right? Well, first of all, let's represent the two numbers because it says find the numbers, right? So I'm just going to, what we don't know is we're going to let x be one number and y be the other. And in this particular case, I'm going to say x is the smaller number, all right, the smaller number. And y will represent the larger number in this particular case. So we start off with, what do we know? We know that a number is one more than twice as large as another number. Okay, so this first number is going to be the larger number, right? So what that tells us is that this large number is one more than twice as large as the other number. The other number was 2. So we know that y equals 2x plus 1. That takes care of this particular statement. What else do we know? We know that twice the smaller number, so twice the smaller number is x, added to 3 times the larger number. So 3 times the larger number is 59. So now we have 2 unknowns, right? And 2 equations. Now you remember when you were solving by the addition elimination, you had to have this in the standard form, ax plus 3y equals c. This is not in the ax plus 3y by equals c. So if you were to use the addition and elimination method, you would have to convert this into that standard form. But if you notice, this is already solved for one of the variables. This expression represents y. Now the book used the addition elimination and it did convert this into the ax plus by. But this is one of those scenarios where I would not have done it the way the book did it. I would have chosen the substitution method because we already know what one of the variables equals. Y equals this expression. So I would use the substitution method, right? And I would substitute this expression in for y. So I'm going to use the substitution method. If you want to see how it's done with the addition elimination method, then you can look on page 169. But I'm going to do that this way. So here I have 2x plus 3. I'm going to substitute for y what I know, which is 2x plus 1 equals 59. Now I have one equation. I'm going to solve for x. So I get 2x plus this 3 times 2x gives me 6x. I got to distribute. And 3 times 1 gives me 3. Still need to simplify before I can solve. 2x plus 6x is 8x. And then I'm going to subtract 3 from both sides, and I get 8x equals 56. Divide both sides by 8. And I end up with x equals 7. Okay, so x is 7. And now I'm going to come back in here. Remember what we said y equals? We said y equals the 2x plus 1. So I'm going to substitute in that 7 to find out what x is. And I get y equals 14 plus 1. And y equals 15. So here our solution then is when x is 7, y is 15. Again, you need to do the check step to plug in and see if you get true statements for both of them. So to me, I saved you several steps by using the substitution method. Let's look at the next example. All right, the next example is a mixture problem. Do you remember we had mixture problems and you had to learn how to do the charts? Last time we had mixture problems, you had to do charts. But in this case, instead of doing the charts, we are going to, again, find two linear equations with two variables, so we have a system of equations, okay? So this is just a different way to solve. Let's talk about what we know and what we don't know. Let me turn to that page. So what do we know? Okay, well, cashews priced at $10 per pound are to be mixed with almonds priced at $7 per pound to make a 75 pounds of mix. Nuts to sell at $8.20 per pound. How many pounds of each should be used? Okay, so what do we know, right? Well, we know that we want 75 pounds total, right, of the mix. We know the cost of the cashews, right? The cost of the cashews is $10 per pound for cashews. We know it's $7 per pound for almonds, right? We also know that the total mix here is also going to be sold. This is going to be sold at $8.20 per pound. So this is what we know. What we don't know is how many pounds of cashews we have. So how many cashews? So what's unknown, right? So I'm going to let C represent the number of pounds of cashews. And I'm going to let A represent the number of pounds of almonds. That's what they're asking for. So here's my two variables. How many pounds of each should be used. So this is my unknown. Now let's look at it and see again and see if we can come up with two equations, right? Well, if we look at this, excuse me, we know that the number of pounds of cashews plus the number of pounds of almonds should equal the number of total pounds of the total mix, right? So we know however many pounds of this and this added together should give us that total 75 pounds, right? We also know that if it's $10 per pound of cashews, so I'm going to say $10 per pound of cashews, if we're talking about price, $7 per pound of almonds, right? And it's $8.20 per pound of the total mix. So this is what we know. Here we have two equations now, and we can solve for the unknown. All right. Now, the book, again, used the addition elimination method. It also went ahead and cleared out all of the decimals. I'm not going to do that at this time. I'm not going to use the elimination. I'm going to use, because these both have a coefficient of 1, I am going to rewrite this so that I can use the substitution method. So I'm going to rewrite this to be, for example, C equals negative A plus 75. In other words, I'm moving that A over to the other side. So now I can take this expression and substitute it in for A here and then solve for C. Okay? Or solve for A. I'm sorry, I said that backwards. This expression, I'm going to substitute it in for C. So here I get 10C, so that was represented by negative A plus 75 plus 7A equals, and then if you take 820 times 75, you're going to get 615. Okay. We're going to distribute this out. So this is going to give me a negative 10A, and 10 times 75 is 750. negative 10a and a positive 10a, so technically they're opposite signs, so I'm going to subtract and keep the sign of the larger absolute, so I'm going to end up with a negative 3a plus 750. And I'm still solving for a. I'm going to subtract 750 from both sides, so I get, I'll just go ahead and do it this way so you can see it. And so when I subtract this, I end up with a negative, I think, 135. And I'm still solving for a. They're multiplying by negative 3, so I'm going to divide both sides by negative 3. This becomes a equals, a negative divided by a negative is positive, and so we end up with 45. Now, what did a represent? A represented what? The number of pounds of almonds. So this is the number of pounds of almonds. All right, just so you know, you got to remember, what did A represent? So then we're going to come back up to our original problem here. And I'm going to take this first equation. The number of pounds of cashews plus the number of pounds of almonds equals the total amount of pounds. We know that A is 45 pounds. So from here we can find out that C is 75 minus 45, or the number of pounds of cashews is 30. So 30 pounds of cashews. Did we answer our questions? Yes, we wanted to know how many pounds of each should be used. Well, we want 45 pounds of almonds and 30 pounds of cashews. And again, you can substitute these both into both of the equations. We already did it in this one because we know 45 plus 30 is 75, right? You could plug it into here and you'd find out that you'd get a true statement as well when you do your check step. Okay, and then the last example problem that they give was this one. It says an investor plans to invest a total of $10,000 in 2 accounts with an annual simple interest rate of 8% and 12%. In other words, the first account is at 8%, the second account is at 12%. If combined annual interest is to be $1,080, how much should be invested at each rate? All right, so you know you're going to be using this anytime when you're talking about investments. Interest equals principal rate times time. So you know that you're going to be using that equation. Just to give you an idea of what we're talking about 2 different accounts here, right? The first account, we have this principal, and it's times 8%, right? Times the time, which is 1 year, right? So I'm just going to put 1. That's the first account. The second account, we have a principal, and the rate is 12%, again, for 1 year. All right. The question they're asking you is how much, and what is the principal amount? How much am I going to invest here, and how much am I going to invest here? That's what it's wanting to know. So let's talk a little bit here about what you know. You know the total investment. Well, what's the total investment? $10,000, right? So you know that $10,000 is the total that they have to invest. So that's the total investment. You know that they're going to earn a total of interest, right? The total interest is 1,080 is the total interest that they earned. And then you also know the individual rates, 8% and 12%. Okay, so that's the stuff that you know. And then what you don't know is this right here. How much are they going to invest for each one? So let's write an equation here. Let's just say that they invest an X amount and a Y amount. There's my 2 variables. I'm going to let X represent the principal amount that was invested at 8%, and Y is the principal amount represented at 20%. And I know that the total of these, the total of this one plus this one, as far as the amount of money that's invested, should equal 10,000 because that is all we had to invest, right? So if I invested 2,000 here, I can invest 8,000 here. If I invested 1,000 here, I can invest 9,000, right? So this is the total amount. The sum of those equals 10,000. Well, I also know that the interest rate, and I'm going to convert this to 0.08. So if I convert this here, this is going to be 0.08, the interest rate, because 1 times anything. So this plus this interest rate, I'm going to convert to 0.12, drop the percent, right? So the interest rate with the amount invested should give me a total interest of $1,080. So there's my 2 equations, my 2 unknowns. And now it's a system of equations. I want to figure out, okay, am I going to graph this? Am I going to use the addition by elimination? Am I going to use the substitution? Right? So what I would do first is I would go ahead and get rid of these decimals here. Okay? You can do that by multiplying this equation. There's 2 numbers behind the decimal, so if I multiply it by 100, that's going to help me clear out my decimals. So this is going to end up being 8x plus 12y equals, now 100 times this is basically going to tack on 2 zeros, right? So now here are my 2 equations. Again, you could take this and you can use the substitution, okay, and solve and use the substitution method. You could also use the addition method. I would not do graphing because you may be dealing in high numbers. But I'm going to go ahead and do the addition method, all right? So we have this equation. We have this equation. I'm going to bring it down so it's right underneath each other. Right? And I'm going to go ahead and do the addition elimination method. So here, somehow I need to either make one of these, need to make this 8 and a negative to cancel out, or I need to make this a negative 12 to cancel these out. So I have to choose, what am I going to multiply the number by? Well, I'm going to multiply this here, and I'm going to do it up here. I'm going to multiply this by a negative 8. All right, so what happens is this becomes a negative 8. This becomes a negative 8y. And then a negative 8 times 10,000 becomes a negative 80,000. All right, so that's how this equation changed. Now I did that so that these 2 here, now I can do that addition elimination method. 8x minus 8x is 0. 12y minus 8y is 4y. And then 108,000 minus, minus 80,000 is, I want to say 28,000. I'm going to divide everything here by 4. And I get y equals 7,000. Okay, 7,000. Remember, this is representing, what is y representing? It's the principal amount. So basically what this is saying, you're going to invest $7,000, okay? So you're going to invest this at 12%. You're going to invest $7,000, right? But now how much am I going to invest at 8%? Well, you've got to take this amount and you're going to substitute it into your original equation. Well, think about it. This was originally x plus y equals 10,000. So if I'm investing at 7,000, what do I have left? 3,000. So x is 3,000 that we invest at 8%. Double check. Do these 2 add up to 10,000? Yes. This is at 7%. This is at 3%. So if you're going to do your check, you do your check step right here. You plug in 7,000, 3,000, and when you get done, hopefully you end up with $1,080. Okay, so that would be your check step. Remember that all preceding examples are types of problems that can be solved with a system of equations in your homework, although not all problems will be exactly like one of these examples. The process can be applied to all the problems involving systems of equations. So you can use this process, and the process they're talking about is at the top of the chart there on page 168, using that process.